Alrighty guys, so in today's lecture we're going to be talking about something called calories and macronutrients. Now I know for sure that you guys have heard that term calorie before, and if you're into fitness and nutrition and things like that, you probably have heard the term macronutrients or macros before. But we're going to talk about it in a little bit more detail. Now before we get started talking about calories, I want you guys to notice that there is a lowercase c calories and an uppercase c calories. The calories that you're more familiar with and the one that we're going to be talking about is the uppercase C calorie. But I wanted to give you guys some information on where we get these terms from. Now, lowercase c calorie is the amount of energy it takes to raise 1 milliliter of water by 1 degree Celsius. An easy way to think about it is this is just a way that we measure energy. It's a unit of measurement for energy. Okay, so if I had a 1 milliliter cup of water, right, very, very small, and I wanted to increase the temperature by 1 degree Celsius, that's how much energy a calorie is. So it's not too much energy. Now, that's the lowercase c calorie. The calorie that we're familiar with, uppercase c calorie, is basically just 1,000 regular small calories. So if we wanted to do a conversion factor, one uppercase c calorie is 1,000 lowercase c calories. Okay, and this is the one that we refer to when we talk about food, but this is where we derive calories from. It's just a unit of energy for, or unit of measurement for energy. It's how we measure energy. Now calories are used to measure how much energy goes into our body and how much energy goes out. So when we eat food, our energy goes up because we're consuming calories, and when we exercise or when we just live in general, right, we're using energy, and so we're burning calories. That's where that term comes from. And so people eat a lot of things, obviously. You guys eat a lot of different types of food, but the food that gives us calories and energy are called macronutrients. Okay, so you guys might hear the term macros. I'll probably be referring to them macros offhand, but macronutrients are basically just food that gives us calories and energy. There's things that we eat that don't give us calories and energy, and those are called micronutrients. So some examples would be vitamins and minerals. Vitamins and minerals don't give us energy or calories, but we do need to eat them because our body needs it to perform basic functions, but they don't give us any energy. The only foods that give us energy are foods that contain macronutrients. There's three different types of macronutrients. There's carbohydrates. You guys probably know this more familiar as carbs, right? Bread, rice, some vegetables because they have fibers in it. They're also carbs. Fats, so you guys probably know like fat. And there's also oils. Oils are just the liquid form of fat. Fat is the solid form, but fats are the other macronutrient. And then the last are proteins. Proteins are made out of things called amino acids. And so if you have a bunch of amino acids linked together like this, and they create a structure, sorry, this is really random, but amino acids stick together and then that will form a protein. Okay, so think of amino acids as the Lego blocks and proteins are the big Lego structure. Now we'll go more into detail, very into detail of all three types of macronutrients, but just know that those are the foods that contain these macronutrients are the ones that give us energy. So things that don't have these macronutrients, they don't give us any energy. They might give us micronutrients, things that we need to eat to survive, but the only foods or the only things that give us energy are these macronutrients. Now, when we eat something like a slice of bread, right? Please don't judge my drawings, but if I eat a slice of bread, right, I'm not just eating carbs. It's not like foods have just one type of macronutrient. Most foods have a combination of them. So when you eat a piece of bread, there's mostly carbs in there, but you might have a little bit of fat, and you'll have some protein in there. Okay, or if you have like a steak, right? And then this will be the eye of the ribeye. I don't know. This is a steak, okay? Obviously, drawing is not my specialty, but if we have a steak, you're going to have some protein in there, and you're going to have some fat in there as well. Or if you have like a vegetable, I'm going to draw a leaf. But if you have some type of vegetable, you're going to have some carbs in there, You might have some protein in there. But the point is that different foods have a combination of these macronutrients. And it's not like you're just eating one in isolation, unless you're straight up drinking like olive oil, right? Or if you're drinking a protein shake. Actually, even in protein shakes, there's carbs. There's usually carbs and fat in there. But unless you're drinking straight up olive oil or something like that, or just eating straight up sugar, you're not eating just one macronutrient by itself. You're eating a combination of these things. Okay. And so these macronutrients give us energy. And when you eat the calories, when you take in food, your body converts that energy um, from the calories in the food into energy that your body needs to survive. And so what we're going to do here is we're going to look at how calories are used in your body. Okay, so here we have a diagram of the human body just so we can visualize it. But let's talk about how the energy is used. About 50%, and so about half of the energy that you take in from food, it's wasted actually. And so we all know that humans are warm-blooded, and so we produce our own heat, and so we give off heat into our surroundings. And about 50% of the energy we get from food is used is wasted as heat. We just lose it to the environment because we need to maintain our body temperature. And we also waste it through something called entropy. Now, entropy is just kind of a fancy way of saying randomness or things breaking down. And so when we eat, our digestive system, or typically our small intestines, takes the food that we eat, breaks it down, and absorbs it. And the energy needs to, travel throughout the body. We need to process that energy. That energy needs to travel to different parts of our body to be used. And so as it travels, we lose some of that energy, and that's what entropy is. Entropy is just breaking down, randomness, disorder, and so when we eat food, it's processed by our digestive system, but as it travels to different parts of the body, we lose some of that, and that's what energy is. So about half the energy that we get from food is wasted. About 30% of the energy that you get from food, we use it to just live, to maintain our body function. So to make sure your heart keeps beating, to make sure your brain is functioning, to make sure your muscles and your other organs have nutrients in them just to keep them alive, because they can't just chill there. They need nutrients constantly to survive. They need energy constantly to survive. So that's where about 30% of the energy goes. And less than 50% of your energy is used for things like growth, to repair parts of your body, like when you get hurt or even when you don't get hurt. Your body constantly needs to repair itself just from the breakdown of living, and for exercise. So that's why a lot of you athletes, when you exercise, you notice you get more hungry, and it's because your body has used more calories. Obviously, it's used more energy, and so it needs to replenish that through more food. Now, before you guys tell me that, Mr. O, this doesn't add up to 100%, right? Because we have 50, we have 30, and we have 15. So that's 95%. So where is the other 5%? Okay, so I just want to point out that these are approximate. It's about 50, about 30, less than 15, and so we don't know how everybody uses 100% of their energy, right? Because these numbers aren't exact, right? It could be more than 50, maybe a little less than 50, more than 30, less than 30, and so every body uses energy differently. And so we don't have an exact number, and so that's why these are approximates. Just keep that in mind. I can add. I know this isn't 100%, but these are just approximate values of where that energy goes. Now, the only way for us to get energy and calories is by eating food. That's where our energy comes from. We're not like plants. We can't just sit in the sun and make our own food. We have to eat food to get calories. And so when you eat food, the calories in your body, the energy in your body goes up. And when you exercise or just live in general, the energy goes down because we need to use energy to stay alive. Now, we all know this, and we might not like this process, but it is necessary. The food that goes into our body that we don't use is stored in the body as fat typically, and so if you take in more calories than you're using, you're going to store it as fat, and so that comes to the topic of weight loss. I know that some of you guys might want to lose some weight. Some of you guys might want to gain weight, right? If you're in sports, you want to bulk up, you want to make weight for weight classes. Some of you guys might want to gain weight or lose weight. Now, there's a lot of different strategies and diets and techniques out there, but weight loss and weight gain is very simple, okay? Let's start with weight gain. If you want to gain weight, it is very, very easy. You eat more than you use, right? Very simple. You just need to eat more than what you use. So if you're exercising, or if you're just not even, when you're not exercising, if you're just chilling, but you're eating more energy, more calories than your body needs, your body's going to store that as fat, and that's how you gain weight. For athletes, you probably need to eat more, and your body's going to use that to build, right? Because we talked about growth earlier. It's going to use it to build more structures, typically muscle mass, but it could also go to bone density. It can go into your tendons. And if you're a teenager, you're growing, just everything is going to grow. It's going to use the nutrients and energy from the food that you eat. So you want to gain weight, you eat more than you use. And for weight loss, if you want to lose weight, it's very simple. You eat less than you use. Okay, and this is called a caloric deficit. Okay, so you use more, you eat less than you use. So you need to use more than you're taking in. Okay, so it's very simple. Weight loss and weight gain. It's a simple system. People make it very complex, and there's some strategies that can help you, right? Everybody's different. Some people want to go on a different kind of diet than other people because they like the food better, or it's easy to maintain. But the principle is the same. It's just basic math. Now, we can talk about cardio and strength. We're going to talk about the difference between cardio and strength training for weight loss, because there are different opinions about this. But it's a very simple system once we know how our body uses energy. Okay, so let's get a couple things clear. Okay, while you are exercising, cardio uses more calories. Okay, so during exercise, cardio, you use more calories to do cardio. Okay, strength training, during exercise, you use less calories. So at a glance, you might think, hey, it's better to run than to weight lift if I want to lose weight. But that's not the full picture, because if you guys remember, how much energy is, or what percentage of your energy is used for exercise? We said less than 15%. Where we use more energy than during exercise is to maintain our bodies. And so the thing about cardio is that you don't build that much muscle mass, right? So we'll say less muscle mass, typically, right? So if you look at a marathon runner versus like a power lifter, a bodybuilder, you can see that obviously the power lifter or bodybuilder has more muscles. Okay, and so if you look at, so if you have more muscles, what does that mean? It means you're constantly burning calories throughout the day in order to keep those muscles alive. And we said earlier that about 30% of the energy that we take in is used to maintain bodily function. So if you have more muscle mass, your body is going to be using more calories throughout the day in order to keep those muscles alive. And so let's just think about it. Even if you exercise a lot, right? Let's say you're a crazy focused athlete, just focused on cardio, and you run 3 hours a day. Okay, and let's say that we have equal. Let's just keep things equal. You do strength training for 3 hours a day. Okay, so during those 3 hours, the person who does cardio is going to burn more calories. But we know that there's not only 3 hours in the day, there's the other 21 hours. The other 21 hours, the person who does strength training is going to be burning more calories because they have more muscle mass, right? Their body needs to make sure that the muscles stay alive. And so they're using more calories to keep things alive. And so just think of it this way. Cardio would be like having your car run very fast for 3 hours. Whereas strength training would be for 3 hours you run your car at a moderate speed, but then it keeps going at a slow speed for 21 hours. And so Strength training would burn more energy by that analogy, and it would use more calories in general. Now, I'm not advocating only do strength training. Obviously, it depends on the sport you're doing, but in order to, if your goal is weight loss, right, you want to combine the two. You shouldn't just do cardio if you want to be as effective as possible, because you're putting yourself at a disadvantage because your body uses more energy keeping your muscles alive than just doing exercise for a couple hours a day. And so just wanted to clear that up with you guys. All right, so we are going to be doing some food stoichiometry to finish out today's lesson. I know you guys love stoichiometry, so take a second to write down these steps, okay? There's 5 steps, but it's actually simpler than regular stoichiometry. The first step, you want to balance the equation. Step 2, you want to determine the given and the end. Step 3, you're going to use the grams of food and find the grams of macronutrients. We'll talk about what that means in a second, and we're going to use the nutrition label for that. Step 4, we're going to turn grams of macronutrients into kilojoules, and we're going to use the energy density table, which is right here. And then step 5, we're going to do kilojoules to calories, and we're going to use this equation right here. Now, for today, we're not going to be doing steps 1 and steps 2 because I don't want to dump that on you guys yet. Instead, we're going to be just doing steps 3, 4, and 5. So make sure you have all these steps written out because you will need them eventually for this unit. But to just know that for today, we're going to be using steps 3, 4, and 5. We're not going to be doing full food stoichiometry. Okay, pause the video if you guys need to do that, but I'm going to move on right now. Okay, so let's do an example problem, and you're going to see a couple example problems like this on your assignment today. So what we're going to do is we're going to calculate how many calories in one Oreo comes from each macronutrient using the nutrition facts below. Okay, so what we're going to do is we're going to go down and we're going to take a look at the nutrition facts for Oreos. I love Oreos, and that's why I chose this. I probably eat more than I should, but we're going to look at Oreos. Now, the key thing to remember is that we need to look at the serving size. If you look at the question, it's asking for what? 1 Oreo, okay? So we're just looking, we want to find the information for 1 Oreo. But if you look here, what is the serving size? The serving size is 3 cookies. It's 3 Oreos. That means in order to find our information, what we need to do is we need to divide everything by 3. That's how we're going to find the information for 1 Oreo. Now, we're going to be looking for how many calories are in 1 Oreo from each macronutrient. We said that the macronutrients earlier, the 3 were fats, carbs, and protein. Okay, so first thing we're going to do in this problem is we're going to find out how many grams of fat, how many grams of carbs, and how many grams of protein are in 1 Oreo. Okay, so I'm going to write them right here. Okay, so let's look at fat. Okay, so it looks like in 3 Oreos there are 7 grams of fat. There's different types of fat, right? There's saturated, trans, unsaturated fats, but these are just types of fat, so we're going to look at just total, okay? So there's 7 grams in 3 Oreos, so we got to do 7 divided by 3, so that means in 1 Oreo, we have about 2.33. Okay, so we're going to put 2.333 grams in 1 Oreo. Let's look at the carbs. We got 25 carbs, right? We said earlier that there's types of carbs like fiber and sugars, but we're just going to look at the total carbohydrates. So there's 25. So 25 divided by 3, because it's talking about 3 cookies, we got 8.33. So 8.333 grams of carbs. And then for the protein, we have 1 gram of protein in 3. So not too much protein in an Oreo, but we're going to divide that by 3. And that's how we're going to get 0.333. So we got 0.333 grams in 1 Oreo. So now that we have our macronutrients for 1 Oreo, what we're going to do is we're going to start finding out how many calories do we get from each of those. Okay, so let's start with fat. So what we did step 3, we found the grams of food, macronutrients based on the food, and we're going to turn that into kilojoules by using this table. So let's start with fat. So we said in 1 Oreo we have 2.333 grams of fat. Now, if you look at the row for fat, it says that there's 37 kilojoules per gram. That means 37 kilojoules equals 1 gram of fat. And so we can set up a conversion factor. Okay, we're going to put grams of fat on the bottom because we want to get rid of that, and we want to find kilojoules. So we're going to put kilojoules on top. And the number next to kilojoules is 37 per 1 gram of fat. And so here we can cancel out the grams of fat, and that will let us find kilojoules. And so what we're going to do is we're going to go 2.333 times 37. And so that means inside one Oreo, you get 86.321 kilojoules from fat. Now, we don't want to stay at kilojoules, and that's where step 5 comes in. We're going to turn kilojoules into calories, so we're going to set up one last fraction. So 1 kilojoule, right? Kilojoule goes on the bottom because we want to get rid of it, and we want to find calories. The number next to kilojoules is 1, and the number next to calories is 0.239. Kilojoules cancels out, and so from here, we can just multiply it by the number on the top, 2.39, or 0.239. And for our final answer, we're going to get 20.63 calories. So that means that in one Oreo, the fat in one Oreo gives you 20.63 calories. Okay, so if you feel confident trying this with proteins and carbohydrates, you guys can do so and pause the video and try it. But if not, it's okay. I'm going to take it step by step for you guys. Okay, so for carbohydrates, we have 8.333 grams of carbs in one Oreo. We're going to set up a fraction. We want to get rid of grams of carbs, so I'm going to put grams of carbs on the bottom. I want to find kilojoules in this first one, so I'm going to put kilojoules on top. It looks like it's 17 kilojoules in 1 gram of carb. So I'm going to put 1 on the bottom, 17 on the top, and then the grams of carbs can cancel out. Now, for those of you that want to just do it in one step, you guys can actually set up another fraction. Put kilojoules on the bottom, put calories on top, and then you just put 1 kilojoule on the bottom, 0.239 on top, cancel out the kilojoules, and you can set it up this way. You can do it the way we did in the beginning with 2 separate equations, or you can do it in one equation. Doesn't really matter, whatever you're more comfortable with and whatever makes more sense for you. So we're just going to multiply the tops, and since the bottoms are just 1, we can ignore those. And so the calories that we get from carbs is 33.857 calories. So when you eat an Oreo, you're going to get 33.857 calories just from the carbohydrates. And then lastly, for the protein, we have 0.333 grams of protein. We're going to set up a fraction. I'm going to put grams of protein on the bottom. I want to turn that into kilojoules, and so here we look at the table. It's 17 kilojoules of energy from 1 gram of protein, and so we're going to put 17 on the top, 1 on the bottom, cancel these out. We're going to set up one more fraction, put kilojoules on the bottom, put calories on top, and there's going to be 1 kilojoule per 0.239 calories. And then kilojoules cancels out, and then we can calculate out for the calories from protein. So 0.333 times 17 times 0.239, and that's going to give you 1.353 calories. And so that means that when you eat an Oreo, the protein in there gives you 1.353 calories. Alrighty, guys. So hopefully that was helpful. I'm on the Zoom call right now, so if you guys have any questions, make sure you guys let me know. But good luck on your assignment, and we'll see you guys next time.